Going on now to topic 6 of chapter 3, doing a little review, we have the word relation, domain, range, and function. Now, when we think of what is a relation, a very good example would be the ordered pair, where the x is related to the y. So there's a connection, that is, this is a relation. Now, in the word domain, by definition, it is the x elements of a relation, and the range are the y elements of a relation. And we'll review this again, but a quick definition of what a function is. A function is when the x element is only used once in a series. So, for example 1, we are asked to find the domain, and the protocol for it would be to put a D, a brace, and then you look at the x elements. Well, as we see them, they're all the same. So we write it once. If it's repeated, we don't write it again. So the domain of this set of relations is a -1. Now the range would be the y elements. So -4, -2, 0, 2. And you can put them just in the order they come. Now for this next one, the domain is 7, 5, 3, 1. Now when we look at the range, we see they are repeated, so we only write it once. Now for number 3 and 4, they're asking us to look at these same relations and see if they are a function. Well, as we look at 3, is the x element repeated? Yes. So it's not used just once. So this is not a function. And as we look at number 4, we have a 7, 5, 3, 1. Are the x elements repeated? No. So this is a function. Now, again, if I were a student, I might take this notes down somewhere, put it on a little card if needed. This is something you want to remember. Now in number 5, they're asking us for what is called a vertical line test. And the vertical line test is if you have a vertical line that's sort of thin, and then you're going to take this line and move it over the face of your graph. This is the vertical line. Now, as this vertical line moves over the graph, does it intersect these points in more than one place as it moves over the line? Well, here it's going to be 1, here it's going to be 1, 1, 1. So we say that this set of points passes the vertical line test, and if it only intersects in just one place, yes, it is a function. Now, as we take that same vertical line and move it across a circle, you see when it gets here, it intersects there and intersects in 2 places all throughout the circle. So would this pass the vertical line test? No, because it intersects the graph, the circle, in more than one place, as it passes over the face of the graph. So this is not a function. And what do you think about 7? Would it pass the vertical line test? Well, no, it's intersecting there and there, so this is not a function. And how about this parabola? As you move that thin line over the face of the graph, does it only intersect in one place? Yes, it passes the vertical line test. So this is a function. Now, for this next part, what we're looking at is, given this function, this is function notation. Remember, we can always replace this function notation with a y equals this. And they want us to think of, if we have something going into something, and I should put this up here. This is your input into this system, and we're inputting some x value, goes into this system up here, and then the output is your y value. And a good way to do this and organize this is to put it in that t-chart. So there's the x values that we have here, which are listed right there. And now what we want to do is put that in there and then find our y values. So I'll do one with you. If this is a -2, -2 squared is 4. And then a -4 times a -2 is a +8. Just substituting, I get a 12. And I can do the second one because they're both 0. This is 0, this is 0, then that is 0. And then you do the same for these in both cases. Notice now here, the negative is not squared. So whatever you put there for the x, that is squared, but then it becomes negative. So this term will always be negative, regardless of whatever is squared. And then we add a +1, and there are our values. Now, at looking at these, I noticed a student was working on one of these the other day, and when I looked in, and he had said he got the answer wrong, for instance, the approximate cost in 1998, you go 1998 right here, and you kind of go over here, it's right about there. See, there's a 9. Now, if you just put a 9 over here in the answer column, they're going to count that wrong. You had to realize that here, these numbers are in the thousands. So you had to add that. Okay? That's a little tricky. And then, of course, in the year 2000, it's right on the line. And does this graph pass the vertical line test? Again, that vertical line, it's only intersecting in one place, so yes. And going on to number 18, they're changing it a little bit. Here's our function of producing X units of a product. Well, what would be the cost of producing 500 units? Well, where the X is, you put 500. Then 500 times this minus the 10,000 gives you 12,500. In this example, they're asking you now to find the domain and the range of each relation graphed. All right, so there's the graph. Now this is going on to this direction. And again, our x's are the domain. So if we think of the domain starting out here at negative infinity, and that's how we would write it, and it's going up to right there, 4, and notice there's a dot on 4, so that indicates 4 is included in the set. So this is the domain. Now the range, this line kind of goes all the way down this way too, so this is coming up for the range from negative infinity, that's down this way, coming up, going all the way up to our point here, which is right there, 3, and that's with a bracket. So there's our domain and our range in interval notation. All right, in example 20, this is a little tricky. And as you read it, they're saying f of x is evaluated at 0. The answer is 4. In other words, when x is 0, y is 4. So when, and in reading that over, I realized I had it backwards. Okay, so it's good to read things over and look at them carefully. So here's the key. When x is 0, y is 4. 0, 4. When x is 3, y is 5. 3, 5. So we have actually a relation of two ordered pairs. They want us to give a function in this form. So we're going to use formula 3 to find the slope. 4 minus 5 over 0 minus 3. So this becomes a negative 1 over a negative 3. So our slope is 1/3. Now notice this point here is in the form 0, b. That's the y-intercept. So our equation then will be y equals our slope 1/3 x plus 4. And if we wanted to graph that, by the way, we would put a dot at 4. 1, 2, 3, 4. We're going to have a run of 3. 1, 2, 3. A rise of 1. And there is our graph. And by the way, if you were to put this into MATLAB, they'd count it wrong. And you might say, well, how come? Well, because they're asking for it in function notation. So we have to change this to f of x. I'm glad I caught that, because then you'll be saying, oh, bonus point. All right, Math Star. Hey, good luck. We kept this down to just 14 minutes.